So, all of our previous problems having to do with free fall had an initial velocity equal to 0, whether that had been the ones that fall or are dropped, or the ones that are thrown sideways. They all had the same Vy as 0. So, this time, let's say we have a Vy going in the upward direction. So, James Harden flops again, but this time he throws the ball straight up with a speed of 9.8 meters per second. It reaches the top of its arc after 1 second. What is the velocity at the top of the arc? So, right here, we have 9.8 meters per second. That would be our Vy. I'm just doing that to make sure I hold myself accountable, to keep it consistent. My delta t is equal to 1. And as always, my acceleration is still equal to negative 9.8. Never changes from that number, as long as it's talking about vertical stuff. My unknown is my V final at the top, or the one right here. So right at this point, at the top, is our unknown. The only equation, which I put the equation sheet in the resources folder of the classwork section, so go ahead and check that out, save it, download it, whatever you need to do to make sure that you have it as a reference point. So A is equal to Vf minus Vi over T. All I got to do is solve it. So A is negative 9.8. Vf is what we're solving for, minus 9.8 is equal over 1. Negative 9.8 is equal to Vf minus 9.8. To get this to the other side, we add 9.8 to both sides. And what do you know? It's equal to 0. So, in all reality, we don't need to do all that math for this type of problem right here. We should pretty much understand that if you were to throw an object up, in order for it to come back down, it will have to cross back from positive velocity into a negative velocity, right? So if you've ever thrown something up in the air, you'll notice it kind of hangs in the air before it comes back down. At the tip, at the very peak of that motion, the velocity will always be equal to 0 because it is transitioning from going up to going down. So if you remember any sort of velocity chart, basically what's happening is we start here in the positive section. We're going to negative. Over time, it reaches the cross section right here of 0, and then it travels into the negative direction with the same constant slope of negative 9.8. This is basically the peak of the motion. And if you were to look at it on a PT graph, it would look something like this. Literally, it would look like that. It's great. Makes so much sense, actually. All right. So, let's keep going. So what we're saying right here is initially it was 9.8 at going up, and then it comes back down, and just before it hits the ground, at the exact same point that it got thrown up from, we want to figure out the velocity there. So all you have to do is look at it. The height is the same. So if the height is the same here, then that would mean all this is negative 9.8. So if the height at any point is the exact same, it will be the same magnitude. Oh no, lights went out. Yeah. I'm trying to do, trust me. Okay. All I had to do was stand. We're going to keep that in. So same height on either side. This side will be positive. This side will be negative. The number will be the same. So right here, it's just negative 9.8. Moving on. So let's say it took 1 second for the ball to reach the top. How much time would it take for the ball to reach the same point that it was launched? So travels one height up, 1 second. And if it falls the exact same height back down, you can assume that it would take another 1 second to reach the ground. So the total time in which it is in the air is that 1 plus 1, which gives us a value of 2. Pretty straightforward stuff. If you are confused, ask me for help. So how far did it travel from the bottom of the arc to the top? This time we are going to actually have to do some math. So guess method it up. So G V I is equal to 9.8. So that's positive, right? Delta T is equal to 1. A, again, equal to negative 9.8. We want to find the displacement. It's equal to question. All right. Now, the only equation that has these 4 values is, that hurts my eyes. Delta D equal to VI times T. Oh, I'm having to squint. Plus 1/2 A times T squared. Now we just do substitute and solve. So displacement is equal to VI, which is 9.8. So we can't just cancel that side out. Times 1 plus 1/2 times negative 9.8 times 1 squared. 9.8 times 1 is just 9.8. Negative 9.8 times 1/2, negative 4.9. 1 times 1 is 1. So 1 times negative 4.9 will still be negative 4.9. So if you subtract the 2, you'll get a value of 4.9 meters is how far it traveled up to that point. So if we check that out, math it up, yes, indeed, that will be equal to 4.9. So this is pretty much the exact same as the previous problem, so I'm not really going to spend too much time on the first half. The only difference is that T is equal to 2. So when we go to plug it into the formula, which is delta D is equal to VI times T plus 1/2 A times T squared, all we got to do is switch T to 2. So 9.8, because it's positive, times 2, plus 1/2 times negative 9.8 times 2 squared. Alrighty, so that would be equal to 19.6 plus 1/2 times negative 9.8 times 4. 4 divided by 2 is simply equal to 2. 2. I'm going to cross that out. Now we have 19.6 plus negative 9.8 times 2. 2 times negative 9.8 will just be negative 19.6. So 19.6 minus 19.6 is, oh my goodness, equal to 0. Because it was thrown up and lands straight back down. So that makes sense that the starting point and the ending point give us a value equal to 0, since they both started and ended at the same point. Also, if you didn't want to have to do all this math, let's go ahead and think about it this way. So we go up 4.9. If we travel back down the same distance, we are traveling 4.9, but since the direction matters here and we're looking for displacement, not total distance traveled, we gotta be negative. So this side plus this side gives us a value of 0. Okay, so your key takeaways from this type of problem. Number 1, acceleration is always negative 9.8 when we are looking at vertical motion. So something that is dropping or falling, basically anything that is going up or down, it will always have a negative 9.8. We have had problems where cars or runners are going to the side, they're slowing down, they're coming to a stop. We aren't looking for its vertical acceleration at that time. We are looking for the horizontal acceleration at those times. But anything that travels vertically will have a negative 9.8 meters per second squared acceleration in the vertical direction. Velocity at the top of the arc is always equal to 0 because at some point it's going to have to come back down. So it has to cross 0 at some point. The closer to the top of an arc, the slower an object is. So up here, slow, fast. Closer to the ground, the faster the object is. So if we compare it on this side, still slow at the top, faster because it accelerates. You can even test this yourself. You can throw something up in the air. If you throw it fast enough, it will look like it kind of hangs in the air for a second and then drops back down really quickly. Okay, this one I also covered. The same height, up or down, means it has the same speed. So if we want to look at it right here, at the top of the arc, we have no difference. This v is equal to 0. At the bottom, we had to give it an initial speed. Let's just say plus 10, just to make it easy. Since these two objects are at the exact same height, they're in line with each other, this one will have the same magnitude, except it will be negative. Up here, since it's slowing down, let's just say it's halfway up, so it's got a smaller arrow. This time it's plus 5. Since this is perfectly in line, this will be minus 5. You notice these rules apply from earlier. The left side, bottom, is faster because it's closer to the ground. On the right side, it's still faster, right, than the one above it. As they get closer to the top, they get slower. And as they are barely leaving the top, they are also still slow. And of course, they have to be equal to 0 at the very top before it transitions from positive to negative. You will understand that as long as you understand how graphs work. So in order to get to the negative side from the positive, you will have to cross 0. Okay. So with that, the only thing you have left to do before you can enjoy your weekend is finish my test. So A-Day people, you need to finish it before midnight. Thursday, B-Day people, you need to finish it before midnight. Friday. The test will not open for the B-Day people until Friday, and the test will not open for the A-Day people until Thursday. It is closing at midnight. I will be awake, and I will shut it down. Click no more accepting of the forms. So make sure that you send it and submit it before that time. Okay? You got plenty of time to do it. You can use your notes. I don't really care as long as you are working on it and get it done. Okay? It's very important that you do because this is a big chunk of your grade. So do it, do your best, and you should be okay. If you have any questions during it, I'll do my best to answer them, but I won't really give any answers away like I normally do. All right? Wish you the best of luck. I will have a video clip here that you can watch after you're done. Talk to you guys next week. Oh, last thing. Next week, join Zoom at the beginning. That is very important. Do that. Okay? You'll be counted absent if you're not in Zoom. So join Zoom. Join it!